Greetings from Oxfordshire in the UK. Thank you for inviting me to speak to you today. It's a huge pleasure. This thesis examined the effects of age-related changes to the female singing voice over a period of 4 years. There were 54 volunteers in 3 groups: professionals, amateurs and non-singers. The amateur singers were the main cohort. Comparative data was drawn from all 3 groups tested at the start of the research, and the examiners noted that this study was a significant contribution to the knowledge in this field, a timely study of growing importance to an aging population, and the tests employed were innovative in their conception, design, and application. The literature suggests that age-related changes could affect respiratory function, vocal folds, vocal tract, tongue, teeth, temporomandibular joint, hearing, digestive system, neuromuscular changes, and other changes caused through menopause. Functionality was tested in these areas, and this list was devised from the pedagogical literature from the 18th century onwards, my own experience of working with the mature voice over 30 years, the literature review, and questionnaires given to choral conductors and singing teachers. There is an assumption that a woman will lose the highest notes and gain lower notes, and this is considered due to normal hormonal changes due to menopause and other age-related changes. These changes include ossification and calcification of the laryngeal cartilages, which can cause restriction to high-frequency voice production. A decrease in estrogen levels may cause the vocal folds to swell, leading to changes in the vibratory characteristics of the voice. An increase in the level of progesterone can cause dryness of the mucosal membrane, causing vocal discomfort. A change in the progesterone level can also be the cause of hoarseness and a more full-bodied sound, and women may also experience vocal fatigue and lower vocal intensity. Maximum phonational frequency range is a useful diagnostic tool for assessing the functionality of the voice objectively and non-invasively. The volunteers were asked to sing ascending and descending scales to demonstrate their maximum frequency. The highest and lowest notes sung were noted at each of the 4 data collections. The data from the main cohort of singers were collated in this Excel spreadsheet, and the graph shows the highest and lowest pitches sung at the first and the last data collection. An initial visual assessment shows that there was no overall trend among the volunteers. The results were very varied. Expressed as percentages, changes to the higher pitches were 25% of the volunteers had no change in their highest pitch, 44% stayed the same, and 31% had a reduction to their highest pitches. And to the lower pitches sung, 22% had no change, 30% had higher pitches than in the first data collection, and 41% had lower pitches. This data was also analysed using JASP statistical analysis software to investigate whether or not any of the changes were statistically significant. The first paired samples t-test examined the highest pitches sung in each data collection. The first was compared to the second, second to third, third to fourth, and finally the first to the fourth. If the results concurred with the expectations in the literature, then the first data collection pitches would be significantly higher than the fourth, i.e. that singers lose their highest pitches in their voices over time. However, the change was non-significant, reflecting the wide variation of individual results. A second paired samples t-test examined the lowest pitches sung at each data collection. Again, the first was compared to the second, second to third, third to fourth, and finally the first to the fourth. Again, if these results concurred with the expectations in the literature, the pitches sung in the first data collection would be significantly higher than in the fourth. The result here gave a significant change for the results between the third and the fourth data collection, but not for the first to the fourth. So the conclusions were there is no predictable linear decline to maximum phonational frequency range due to age-related changes. Change to pitch range is not exclusively age-related, as it can occur in younger singers too. The menopause can cause pitch changes in the mature female voice, but not all women experience the same changes. While some have significant changes, others have almost none. The volunteers' questionnaires showed that regular singing can maintain maximum phonational frequency range, as those who reported having regular lessons and singing at least 4 times a week scored better than the others. Thank you so much for listening to me today. If you have any comments or questions, please do contact me at this address. And thank you to my lovely ladies who all took part in my research. Thank you.